Welcome to TrueTech Academy. Hello students, my name is Shankar, chemistry faculty. Today we are going to discuss about solutions. The name of the topic is solution. In previous classes we started different concentration terms used in solutions chapter. So we'll go to further. So the next one is solution. We are discussing different concentration term. Now the term is strength of solution. In short, we will write SOS. So in short, we will write SOS. So strength of solution, I will write the definition so that you will come to know. So it is the weight of solute present in 1 liter of solution. So strength of solution says weight of solute present in 1 liter of solution. So in previous weight percentages, what is the definition? Weight of solute present in 100 gram of solution or 100 ml of solution. Percentage means we taken out of 100. But here in strength of solution, we are going to find weight of solute per 1 liter. So 1 liter of solution. So the formula will be, so strength of solution equal to weight of solute by volume of solution in liters. So the formula is strength of solution equal to weight of solute. Here W indicates weight. So V indicates volume. L indicates in liters. Or simply you can write no problem. Okay. So strength of solution, it is the weight of solute present in 1 liter of solution. Otherwise, you can write in ml also. Then on the time the formula will be weight of solute by volume of solution in ml into 1000 ml. So this is also another formula. This formula is used when the given question contain volume term in liter. If the given information is volume of solution ml, simply we can multiply with 100. So this is how we are going to get strength of solution concentration term in terms of strength of solution. So this can be modified further. If you observe this one properly, this can be modified like this. Weight of solute into 100 into 10 divided by volume of solution in ml. So this can be written in this manner. 1000 can be written 100 into 10. So from this you can say this part, weight of solute into 100 by volume of solution, indicate weight by volume percentage. So this term indicate weight by volume percentage. So up to this part, except this 10, this part indicate what? Weight by volume percentage, and the next one is 10. into. So accept this 10 remaining weight of solute into 100 by volume of solution in ml indicates weight by volume percentage. So this is how strength of solution is connected with weight by volume percentages also. Weight by volume percentages also. So this is the another formula for strength of solution based on the given information in the question. If the given information is weight by volume percentage, this formula we will use. Okay. Next, we will go to next one. So next one is parts per million. So next term is eighth one, parts per million. In short, we will write ppm. ppm, parts per million. So here our interest is to find out the amount of solute in 1 million parts. 1 million parts. So simply the formula will be ppm. ppm equal to simply number of parts. Number of parts. Number of parts of solute divided by number of parts of solution. Number of parts of solution into 10 power 6. So please try to see the, so it is the parts per million, So because of million, we taken 10 power 6. Because of million, we taken 10 power 6. So simple formula ppm equal to, so previous example we discussed here, instead of parts, what we are getting? Weight. Here parts nothing but weight also. Simply we can take weight of solute by weight of solution. Weight of solute by weight of solution into 10 power 6. So here parts nothing but weight also, or if there is a volume part, volume also. Okay, so this is how. Here parts nothing but what? Weight in grams. If it is in gram, so this solution also will take in grams. Okay, in same units we will take. So this is how another one. So next we will go to another topic, concentration term, molarity. Next we will go to molarity. Before going molarity, so I want to explain a little bit different to understand the molarity clearly. Before going to molarity, so one small topic is there. First I will discuss. It is mole concept. So mole, in chemistry there is a term mole. So the mole is represented by symbol n. The mole is represented by symbol small n. So based on our requirement, so we will limit it to small introduction about mole. Based on our requirement, I will only limit the topic to small one. So there is a formula to calculate the moles. So formula is number of moles. Symbol is N equal to weight of the substance, weight of given substance divided by molecular weight of given substance. So to calculate number of moles, this is the formula. I am not going to discuss about the moles. That is, at this moment it is not required. We require only formula. So to find number of moles is represented by weight of given substance by molecular weight of given substance. So if here weight is taken in grams, then molecular weight also taken in grams only. So all of you know molecular weight of given substance. So this in short we will write, this one in short we will write simply like this. So weight of the substance is represented by W. So molecular weight is represented by MW. Molecular weight is represented by MW. So in some books, molecular weight of the substance also represented by using this one, gram molecular weight. Gram molecular weight. Gram molecular weight. Gram molecular weight. In short, GMW. So if you take like that, it is represented by W by GMW. So molecular weight, gram molecular weight, both are same only. Both are same only. So we will see two examples to calculate gram molecular weight. All those are you know. So this is for molecule. Molecular weight we are taking means it is for molecule. If it is atom, here we will take atomic weight. We will take atomic weight. So this is for number of moles for molecules. Number of moles. This is for molecules. Molecules. For atom, number of moles equal to same weight of the substance by weight of the substance by, here we will take atomic weight. Atomic weight. So instead of molecular weight, here we take an atomic weight because the given compound is what? Atom. The given compound is atom. When atom is the given compound, so we will take atomic weight. When the molecule is the given compound, we will take molecular weight. So we know how to calculate molecular weights. So for example, few examples. So for example, H2O. So H2O. H2, this is molecule we taken. Okay, this one molecule. So how to calculate molecular weight? How to calculate molecular weight? Simple, by combination of atoms we will take. So this one we will write it as a 2 hydrogens plus 1 oxygen. Okay, 2 hydrogens plus 1 oxygen. Then we are going to add it atomic weight. 2 into, we know molecular weight is obtained by adding atomic weights. Molecular weight is obtained by adding atomic weights and number of atoms. So H2O is a combination of 2 hydrogen and 1 oxygen. So 2 into atomic weight of hydrogen is 1, plus similarly 1 into atomic weight of oxygen is 16. So you are going to get 18. This is what? Molecular weight. This is what? Molecular weight or gram molecular weight of water. Okay. So this is how we will find molecular weight or gram molecular weight of a molecule by simple from formula. Molecular weight is determined by using formula only. For example, if you take HCl. So HCl, how to find gram molecular weight or molecular weight? So how many hydrogens? One hydrogen plus 1 Cl. So we know 1 into hydrogen atomic weight is 1. So similarly, chlorine atomic weight is 35.5. So total it is how much? 36.5. Total it is 36.5. So if we take similarly carbon dioxide, so how we will write? 1 carbon plus 2 oxygens. We know carbon atomic weight is 12 plus 2 into oxygen atomic weight 16. One carbon, 1 into carbon, 2 oxygens, 2 into oxygen. One carbon atomic weight is 12 plus 2 oxygen atomic weight is 16. So you are going to get 44. 32 plus 12, 44. This is how we will calculate molecular weights. I think this much is enough at this moment. Simply, our interest is identifying the formula. So finally, simply this is our interest. Moles means, so moles, you need to remember N equal to W by MW or GMW. This one our interest. This formula is our interest. So during our concentration terms. So please remember moles equal to weight by molecular weight or moles equal to weight by gram molecular weight. This is our interest. So we'll go to next one. So next our concentration term is molarity. Next our concentration term is molarity. It is represented by using capital M. It is represented by using capital M. So from first I will write the definition. From that you can understand how to write the formula. So molarity says number of moles, because here we require moles. What I explained previously what is the moles and its formula. Number of moles of solute present in 1 liter of solution. So this is the definition. Molarity says number of moles of. So till now, whatever concentration terms, it expressed in terms of grams, weight of the solute, volume of the solute. Here not the weight. Here it is asking moles, number of moles of solute present in 1 liter of solution. So if you observe from the definition, we can write direct formula molarity equal to, so what it is saying, number of moles. For moles, what is the formula? N. Number of moles. Now present in where? 1 liter of solution. Present in where? 1 liter of solution. So molarity M equal to moles by volume of solution. In what terms? In liters. So in what terms? Liters. So molarity equal to N by V in liters. So this is the formula. So our interest is what? 1 liter. So 1 liter means simply multiplying with 1. Simply multiplying with 1. So 1 no need to write separately. So please all of you please remember. So simply molarity means please remember N equal to N by V in liters. So this much please remember. So in question, if they given volume in liters, simple substitution. In question, if they give volume in ml, we can convert into liters or we can adjust the formula. Other formula is M equal to N. N is what? Moles of solute. Here N is what? Moles of solute. Here N equal to moles of solute. So here now the topic is M equal to N by volume of solution. Here V indicates what? Volume of solution in ml. So here it is multiplied with a simple 1000. So these are the two formulas we are going to use. To calculate molarity. Molarity, if the given information is in later, simple formula M equal to N by V. Here N is what? Moles of solute, volume liter. For example, if the given information is in terms of ml, volume of solution in ml, simple is volume of solution ml, it is multiplied with what? 1000. So whatever you can use, no problem. Okay. Now further it is rearranged to, further it is rearranged to. So in previous class, not previous class, previous slide, in previous slide, we know what is n, w by mw, we know what it is. So simple substitution, on substituting here, this can be modified, m equal to n by v, this can be written like this, n into 1 by v in later. Okay, so similarly n equal to n from previous slide. So in previous slide, what is n? N equal to moles absolute, so it is represented by weight by molecular weight. So here we will substitute here n equal to weight by molecular weight into 1 by v in liters. 1 by v in what? Liters. 1 by v in liters. So this is the another formula we will use when the given information is in terms of W. W means weight. Weight of what? Solute. Weight of solute. Here it is what? Moles of solute. Here it is weight of solute. So this also can be modified. So we are writing in place of n, we are writing weight by molecular weight, W by molecular weight. So remaining as it is, 1000 by, so this is what? Volume of solution in ml. This is also molarity. So this is how molarity, so having different formulas. If you remember a basic formula, it can be changed in different ways. So only by substituting n, n is substituted by weight by molecular weight. Here the volume of the solution is in ml. So here further one word means further one number is multiplied by using 1000. So this is how molarity formulas. Okay. So further we'll go to molarity. So further it can be adjusted. Volume of the solution. Next slide I am going. So if you observe molarity from the previous slide, so if you observe this term, weight into 1000 by volume of solution in ml. So this is similar to what? Strength of solution. Where it is strength of solution? Yes, this is the one. So you see, strength of solution equal to weight of the solute into 1000 by volume of the solution in ml. So weight of the solute into 1000 by volume of the solution is replaced by strength of solution. So if you observe here, from here we can modify. So molarity equal to, so W into 1000 by volume of the solution is represented by using SOS divided by, the term is molecular. So these three terms are replaced by using previous definition, strength of solution. Similarly, same thing can be adjusted by using the previous slide. So here one more term we use. What we use? Strength of solution equal to weight by volume percentage into 10. So in place of strength of solution, we can use this term also. So same thing. So strength of solution, so further replaced by molarity equal to what we written? Weight by volume percentage into 10 by molecular weight. Please, molecular weight or gram molecular weight, GMW, both are same. Molecular weight or GMW, both are same. So this is how molarity having different formulas. So only simple thing is these three terms are replaced by SOS. SOS is replaced by weight by volume percentage into 10. Okay, we will go to some numericals so that you can understand. So how to calculate? So how to calculate molarity? So question 1. Question 1. So we will see the different possibility. Question 1. If they give question 1, find molarity when 2 moles of say 2 moles of NaCl two moles of glucose, I will write. Find molarity when 2 moles of glucose is dissolved in 1 liter of solution. So we'll do 2-3 questions so that you will get clarity. So see, question 1, find molarity when 2 moles of glucose is dissolved in 1 liter of solution. So see from the different formulas, so what information is given? Question 1, answer is, what is given? Given N equal to 2, this is given, N equal to 2 moles. Next, what is given? Given N equal to 2, volume equal to 1 liter. Volume equal to 1 liter. So now, what is the molarity formula? M equal to N by V liters. So therefore, molarity equal to N by V in liters. So simple substitution. So N equal to 2 and volume equal to 1. So therefore, that is equal to 2. So it is represented by using like this. So molarity equal to how much? 2. It is represented by like this. 2 molarity. This is how they will represent. So if the given terms are moles, like this. For example, we are having different terms. So if the question is second question, find molarity when say I will like this, and I will take this one, 36.5 grams of HCl, 36.5 grams of HCl dissolved in 36.5 gram of HCl dissolved in 500 ml of solution. So this is how. So if you observe here, what is given? I am writing solution. So given what? Weights. Weight, how much given? 36.5 gram. Given weight, 36.5. Next, what is given? Volume of solution given. Given volume of solution. Given volume of solution. So this is how much? 500 ml. So given weights, given volumes. So on the time, so what is the formula? We need to take this one. Given information contain weights. So we will use the formula which contain weight, and the given information is what? ml. So we will take this formula. Weight by molecular weight into 1000 by volume of solution in ml. Based on information, so now molarity, so we know the previous formula. So what is the formula? Molarity equal to weight by gram molecular weight into 1000 by volume of solution in ml. So from this molarity equal to so what is weight? 36.5. Weight is 36.5. How to find gram molecular weight? So gram molecular weight, we know how to calculate simply by adding its atomic weights. So HCl, if you take HCl, so its molecular weight is hydrogen, how much? Hydrogen, sorry, is disturbing. Hydrogen 1 and fluorine is 35.5. So gram molecular weight, how much? 36.5. 36.5. So if you want little bit difference, we can change it also, no problem. Can change it. So if you want some difference, I will make it little bit small change. So 36.5, I will take this one, 73 gram. I will take this one, 73 gram, okay. So now, what is the formula? Weight equal to 73 gram, okay. Molecular weight, gram molecular weight, how much? 36.5, okay. Later, what it is there? 1000 by volume of the solution. What is given? 500 ml. So if you observe properly here, it is what? 2 times. It is also 2 times. So total how much? 4. Total how much? 4. So the molarity is 4. It is represented by like this, 4m. It is represented by 4m. So this is how molarity is calculated. If the given information is moles, simply use n. If the given information is in terms of weight, use the formula which contain weight terms. So this is how molarity is calculated. We will go to next. I hope previous slides, whatever terms are there, explained. See, number of moles, n is there, so we done one calculation. Similarly, weight is there, we done the one calculation. Only this one. Here also same thing. If the given information is weight by volume percentage, simple substitute weight by volume percentage here and multiply with 10 and then division with the molecular weight. So next we will go to one more formula is there, that one also included, and then we will go. Another formula for molarity equal to weight by weight percentage into 10 into D by gram molecular weight. So the formula is weight by volume percentage. But in this case, weight by weight percentage. When weight by weight percentage is there, here we included one more term, D. Here D represents density. Here D represents density of solution. So this is how we will calculate a molarity of solution, molarity of given solution. Okay. So many formulas explained. We will go to next. Next, there is a topic, dilution principle. From heading you can understand dilution. Dilution means already some solution is there. To that we are adding fresh solvent. To that we are adding fresh solvent. So here there is a solution. Solution. We are adding fresh solvent. So when there is a solution, to that if you add a fresh solvent, then what will happen? It is called dilution. By adding extra solvent, so concentration decreases. When concentration decreases, we call it as a dilution. Dilute చేయటము. ఏమంటాము? Dilute చేయటం. సో విత్ వన్ సింపుల్ ఎగ్జాంపుల్, మన దగ్గర ఏదైనా సంథింగ్ ఒక ఫుడ్ ఐటమ్ ఉంది, కర్డ్ పెరుగు ఉంది, దానికి వాటర్ వేసాం, ఫ్రెష్ వాటర్ వేసేస్తే ఏమైంది? డైల్యూట్ అయిపోతుంది, మజ్జిగగా మారుతుంది. ఇఫ్ యూ యాడ్ ఫర్దర్ వాటర్, ఇంకా వాటర్ వచ్చేసరికి ఏమైంది? ఇంకా పల్సగా అయిపోతుంది మజ్జిగ. సో డైల్యూషన్ వచ్చేసరికి మనం ఆ విధంగా అర్థం చేసుకోవాలి. సో ఏమవుతుంది? డైల్యూషన్ చేసినప్పుడు ఏమవుతుంది? ఒకసారి అబ్జర్వ్ చేయి. ఇఫ్ దెర్ ఇస్ ఎ సొల్యూషన్ ఉందంటే దానికి మొలారిటీ ఉంటుంది కదా, మొలారిటీ. సో ఇట్ హ్యావ్ సమ్ వాల్యూ, మొలారిటీ సంథింగ్ వాల్యూ ఉంటుంది. వెన్ యూ యాడ్ ఫ్రెష్ సాల్వెంట్, ఎప్పుడైతే ఫ్రెష్ సాల్వెంట్ యాడ్ చేస్తామో సో ఈ మొలారిటీ చేంజ్ అవుతుంది. నాట్ ఓన్లీ మొలారిటీ, ఎనీ కాన్సన్ట్రేషన్ టర్మ్, వెయిట్ పర్సంటేజెస్ కావచ్చు, వెయిట్ ఫ్రాక్షన్స్ కావచ్చు, స్ట్రెంత్ ఆఫ్ సొల్యూషన్స్ కావచ్చు. సో కాన్సన్ట్రేషన్ టర్మ్స్ ఏమవుతాయి? దే విల్ చేంజ్ వెన్ ఫ్రెష్ సాల్వెంట్ ఈజ్ యాడెడ్. సో మన ఇంట్రెస్ట్ వచ్చేళ్ళకి మొలారిటీ ఇనిషియల్గా సంథింగ్ ఏదో ఉంది, సే ఇనిషియల్ మొలారిటీ, సే MI ఆర్ సింప్లీ M1. వన్ అనుకుందాము. ఇనిషియల్గా మొలారిటీ ఎంత ఉంది? 1 ఉంది. సో బై యాడింగ్ ఫ్రెష్ సాల్వెంట్ మనకు వస్తుంది, ఏమొస్తుంది? ఫైనల్ సొల్యూషన్ వస్తుంది. వీ నీడ్ టు ఫైండ్ M final or M2. After addition of fresh solvent, our interest is to find out the final molarity. So ఇనిషియల్గా మొలారిటీ ఉంది, సే 1 అనుకున్న మొలారిటీ, ఫ్రెష్ సాల్వెంట్ యాడ్ చేశాను. నౌ వాట్ ఈస్ ద ఫైనల్ మొలారిటీ? సో టు దట్ వన్ వీ విల్ యూజ్ ద టాపిక్ డైల్యూషన్ ప్రిన్సిపల్. సో దయచేసి చూడండి, సింపుల్. ఇనిషియల్గా సమ్ సొల్యూషన్ ఉంది, ఇట్ హ్యావ్ సమ్ మొలారిటీ. టు దట్ వీ యాడెడ్ ఫ్రెష్ సాల్వెంట్. నౌ కాన్సన్ట్రేషన్ ఇస్ చేంజింగ్. Now the question is, what is the latest concentration after adding fresh solvent? Okay, so ఒకసారి చూద్దాము. It is represented by initial అయితే M1, final molarity M2. There is no restriction 1, 2. Something తీసుకోవాలి కాబట్టి తీసుకున్నాం. Something we need to indicate. M1 is the initial molarity, M2 is the final molarity. Okay, so now the formula is to calculate final molarity. So ఒకసారి అబ్జర్వ్ చేస్తే we know molarity equal to N by V. Just previous నేర్చుకున్నాం. We know molarity equal to N by V. So this can be rearranged to N equal to M into V. So this can be written in this manner, N equal to MV. So if you observe properly, during dilution, N is fixed. What N indicates? Number of moles of solute. N ఏం చెప్తుంది? సొల్యూట్ గురించి చెప్తుంది. ఇక్కడ వాట్ వీఆర్ డూయింగ్, సాల్వెంట్ని యాడ్ చేస్తున్నాం. నో చేంజ్ ఇన్ సొల్యూట్. ఓన్లీ చేంజ్ అవుతుంది ఎవరు? సాల్వెంట్ క్వాంటిటీ అండ్ దెన్ సొల్యూషన్ కాన్సంట్రేషన్. సో డ్యూరింగ్ డైల్యూషన్ దెర్ ఈజ్ నో చేంజ్ ఇన్ వెయిట్ ఆఫ్ సొల్యూట్ ఆర్ మోల్స్ ఆఫ్ సొల్యూట్. కనపడతానే ఉంది, No change in weight of solute or moles of solute. Only change in concentration and quantity of solvent, quantity of solution. So N is constant. N is constant. So it can be written N equal to M1 V1, N equal to M2 V2. What is N? Number of moles of solute. Here N equal to number of moles of solute. Number of moles of solute. So here number of moles of solute is constant during dilution. So during dilution, so no change in the number of moles of solute. So from this, what we can write? So from this, we can write so from these two, this is say 1, this is say 2. From 1 and 2, we can write M1 V1 equal to M2 V2. So from these two, N and N constant kabatti, these two equal chesam. M1 V1 equal to M2 V2. So from this, we know M1 equal to initial molarity, M2 equal to final molarity, V1 equal to initial volume, V2 equal to final volume. M1 వచ్చేసరికి initial molarity, M2 final molarity, V1 initial volume, V2 is final volume of what? Solution. Final volume of solution. Okay, ఇది కూడా same, final volume of solution. Okay, now from this we can find volume of solvent added during dilution equal to V2 minus V1. Volume of solvent added during dilution వచ్చరికి ఏమైంది? V2 minus V1. ఎంత సాల్వెంట్ యాడ్ చేసామంటే ఏంటి? ఫైనల్గా ఎంత ఉంది? ఇనిషియల్గా వాల్యూమ్ ఎంత ఉంది? ఇద్దరి మధ్య డిఫరెన్సే కదా. ఓకే, ఫర్ ఎగ్జాంపుల్ ఇనిషియల్గా 100 ml ఉంది, ఫైనల్గా 150 ml. Initially 100 ml of solution is there, and the final 150 ml of solution is there. Now the question is during dilution, what is the quantity of solvent added means? Difference only 50. So this is how we can calculate volume of solvent added during dilution also. Okay, so we'll do one question also. Now, so question చూద్దాం. Find final molarity of solution when 500 ml of fresh H2O is added to sorry. added to 100 ml of 2 molar solution. So try to understand the question. They are asking find final molarity, latest molarity solution when 500 ml of fresh water is added to 1000 ml of 2 molar solution. So if you observe from question, so what is given? What is given? Given M1. M1 అంటే already చెప్పుకున్నాము. Initial molarity. What is initial molarity is given? 2 molar. What is given? 2 molar. So if unable to appear, I will write here 100 ml of 2 molar solution. So initial what is M1? 2 molar. Similarly, what is V1 initially? 1000 ml. 1000 ml. Now they are asking find molarity M2. So our interest is to find M2 or simply leave it. Our interest to find M2. Now tell me, what is V2? Now the question is, what is V2? V2 is what? So if you observe previous slide, what is V2? Final volume of solution. Final volume of solution. This is initial volume, this is final volume. Final volume means, so initial volume plus volume of fresh solvent added. So V2 will be what? Initial how much? 1000. Now newly we added what? 500 ml. Now this is the V2. So V2 is what? 1500 ml. V2 is what? 1500 ml. So V2 is 1500 ml. Okay, we know the formula how to calculate if two different V1 different volumes are given, one molarity is given, M1 V1 equal to M2 V2. So M1 we know it is 2, V1 we know it is 1000, M2 we want to find out, V2 is 1500. So only the thing here need to remember is, whatever here volume values both should be in the same what is called either in ml units, either in ml or either in liters. If you are taking it ml, here also take it as a ml. If it is in liters, this one also, if given, take it as a liter. If not given, convert it into liters. Both should be in the same unit. So simple. So here what it is, our interest is to find out M2. Our interest is to find out M2. M2 is what? So this term will come here, 2 into 1000, how much? 2000. 2000 by, if it comes, what will happen? 1500. Okay. So finally you are going to get 0 cancel. So you are going to get. So this is how you are going to get final molarity. So final molarity M2 equal to, so this is the volume 20 by 15, or by simple calculation we are going to get the exact value. So here you are going to get the exact values. So this is how we will calculate on doing calculation of 20 by 15, you are going to get 1.33. So this gives 1.33. This is the final molarity of the solution. So this is how to calculate final molarity of the solution. Okay. So simple formula, M1 V1 equal to M2 V2. Here the thing is, we need to take care about V2. V2 is a volume of initial plus freshly added. So similarly, we will go to next one. Similarly, we will go to next one. There is a one more formula. Note point I am writing. Note point I am writing. If different solutions, if different molar solutions are adding. If different molar solutions are adding, different molar solutions of same substance are adding to each other, then final molarity. So if you observe this note point, same substance but they are different solutions. So something is substance అనుకుందాము, say HCl solution ఉంది, ఇక్కడ solution 1 ఉంది, ఫస్ట్ సొల్యూషన్. అదే HCl solution 2 ఉంది, అదే HCl solution 2 ఉంది, సేమ్ సబ్స్టెన్స్ HCl solution 1 2, బట్ దిస్ మొలారిటీ సే ఇది 1 కాబట్టి వీళ్ళు అందాం 1 అందాము, సో దిస్ మొలారిటీ సే 2 అందాము. This is a HCl solution, this is also HCl solution. Its solution molarity is 1, that solution molarity is 2. Now what we are doing, we are adding together. After addition, they are asking what is the final molarity. After addition, what will be the final molarity? So this is the first solution, so this one take it as M1. This is the second solution, take it as a M2. Consider the first solution volume is 3 liter. Similarly, the second solution volume is consider 4 liter. Okay, something values I am allotting. So HCl solution, both are HCl solution only, same substance, but concentrations are different molar concentration. This is 1 molarity, this is 2 molarity. Volumes వచ్చేలకి maybe same or different, no problem. Maybe same or different. Same also we can take it, no problem. Now the question is, so what is the final molarity? So final molarity I am representing like this, MF. Now the formula is MF equal to M1 V1 plus M2 V2 by V1 plus V2. So this is the formula. This formula is used when same substance with a different concentration. Same substance with the different concentrations are mixing together. ఇది వచ్చేలకి దిస్ M1 V1 ఎవరి గురించి చెప్తుంది? ఇట్ సేస్ అబౌట్ ఫస్ట్ సొల్యూషన్. M2 V2 ఏం చెప్తుంది? ఇట్ సేస్ అబౌట్ సెకండ్ సొల్యూషన్. నౌ ఫైనల్గా వచ్చేలకి ఏం చేయాలి? దిస్ ఇస్ ద ఫార్ములా. సో ఇఫ్ యూ సబ్స్టిట్యూట్ దట్ వన్, సో యూ ఆర్ గోయింగ్ టు గెట్ వాట్? M1 is 1, volume is 3 liter. Similarly, M2 is what? 2, volume is what? 4 liter. By total volume how much? V1 plus V2, 3 plus 4. Something is the calculation చేస్తాము. 3, that is what? 8, 11. 11. This is what? 7. So this is how final molarity. This is how final molarity of a solution is calculated when different concentrations of same substance is mixed together. Similarly, ఇంకొక కాంబినేషన్ కూడా ఉంది. సో here I am writing. So here I am writing next side. Second point, note point లోనే second point. Like first point, same substance with the different concentrations we are mixing. To that we are adding some extra solvent also. Mixing fresh solvent to note point 1. Already note point 1 రాసుకున్నాము. Note point 1 కి fresh solvent యాడ్ చేస్తాం. Then what will be the formula? So then final molarity equal to M1 V1 plus M2V2 by V1 plus V2 plus ఏదైతే ఫ్రెష్ సాల్వెంట్ యాడ్ చేసాం కదా, సో దిస్ ఇస్ ద ఫ్రెష్ సాల్వెంట్. సో V fresh solvent also included. So this is the definite. This is the formula. So previous formula up to here. M1 V1 plus M2 V2 by V1 plus V2. Here we are adding V fresh solvent. So it is also included. So instead of writing this entire, simply we can write M1 V1 plus M2 V2 by total volume. Total volume. Here what total volume indicates? These three terms, V1 plus V2 plus V fresh solvent. Total volume. Okay. So please try to understand the formula. Here em chesamu, different molar solutions of same substance added. When you add two different solutions of same substance, this is the formula. 3 add chestamu. When we add third solution of same substance, the formula will convert into M3V3 by V1 plus V2 plus V3. This is how. Okay na? So 4 add cheste, one more term is added. Similarly at the denominator also same thing. Okay. So this is how. Second point ఏంటి, mixing of fresh solvent to the previous note point. So this is the formula. So for example చూద్దాము. Solution 1 సే అదేవిధంగా solution 2 ఇట్లా ఉంది. సేమ్ HCl ఇస్తాము, solution of HCl. Okay, molarity is given, say 1, volume is given 1 liter. So similarly molarity of second solution, say 2 molarity, volume is given V2, say 1 liter. To this mixing చేస్తున్నావు. So these two are mixed. Okay, mix చేస్తున్నావు. Okay, ఫైనల్గా వచ్చేళ్ళకి, సో దిస్ ఇస్ ద ఫైనల్ వచ్చింది. మిక్స్ చేసినాక ఫ్రెష్ సాల్వెంట్ యాడ్ చేస్తాం. ఫ్రెష్ సాల్వెంట్ యాడ్ చేస్తున్నావు. ఎంత యాడ్ చేస్తున్నావు? సే 1 లీటర్. సే 1 లీటర్. 1 లీటర్. Okay, now in this case what will happen? Final molarity equal to M1 V1, 1 into 1. M1 is taken 1, V1 also we taken 1, M2 V2. So M2 is taken 2, V2 is taken 1 by V1 plus V2 plus V fresh. V1 how much it is? So we taken 1 plus V2 how much we taken 1. Freshly we are adding 1 more liter of fresh solvent. So it is what? 3 by 3. This is what? 3 by 3. Okay. So this is how different possibilities during calculation of molarity. Okay. All discuss చేసాము. మామూలుగా how to find molarity discuss చేసాము. When different solutions of same substance mix చేస్తే how to find molarity, and different solutions of same substance mixing and then adding fresh solvent, then also how to calculate molarity. Okay, so this is regarding molarity. So at this moment I'm stopping this class. Thank you. So this is provided by TrueTech